Christian friend of mine who like never forgets to send me a Christmas card, and you can see that smile, right? That's genuine smile. That's the kind of joy that you get walking with Christ. I am not as consistent a person as he or Nico, so there are times when, you know, the enemy like wears me down, like only temporarily, but it's getting better and better. I do need, like, those of you that are out there like Christians, I do need your prayer. So a while back I shared a problem called the ridiculous question, and I didn't title it as such. Like Scientific America, a magazine here in the US, named it as such and kind of posted it as a puzzle problem, and I'll, like, you know, share the link to that problem. But it was a really cool problem, and it relied heavily on the theorem that said that tangents to a circle from the same external point are equal. So this here, this distance from this point to this point is the same as the distance from here to here, right? And so, and that question, you know, it's kind of like silly that I'm doing it in this video, but I'll do it real fast because I'm basically like, don't need to share it, like I'm solving it here. And that problem, you were given the distance from here to here is 10, and that's all you were given. And then you're asked, what is the perimeter of this triangle in here, right? And so you have to exploit that tangents from the same external point are equal theorem repeatedly. So maybe I'll leave it to you, like I'll give you a clue. So this distance is the same as that distance, right? Because this is an external point from which we have two tangents, that and that tangent lines, right? So these two are equal. So you knew that's 10, you know this is 10, and so you finish the job. Now, the question here is very similar, but not quite the same. And I don't know, I don't know which question is better, but like I like both a lot. That was really novel at the time I got it, so I thought it was great. But I really enjoyed this problem. So in this question, what you're given is that this is 4 here, and that this is equal to this. And you're also given that this here is 2, right? And the task is, what is the radius of this bigger circle? R equals what is the question, right? Okay. All right, so how do we do this? You do this, right? So first, you draw a line from here to the center. And this point, this point, and this point have to be concurrent, right? And then we know that at the point of tangency, the radius and the line tangent to the circle have to be perpendicular. So that's a 90 degree right there. But also notice that this here is a radius, right? And this is a tangent. So we have 90 degrees here, which means we have 90 degrees here, which in turn means we have 90 degrees all around, right? Because like this here makes 180, right? So if that's 90, this has got to be 90 on the other side of this line, right? Okay. Like I covered up this drawing with too much, right? Okay, anyway. So, now, we know that this triangle here is isosceles. And this is true only for isosceles triangles, because we're told, that this is equal to that. This is true only for isosceles triangles. But if we have an isosceles triangle, the altitude, and we know this line from here to here is an altitude because it's perpendicular to this base, right? The altitude in an isosceles triangle is also the angle bisector and the median. So meaning that this angle here is the same as this angle here, and more importantly to the task at hand, this is equal to this. In other words, the segment from here to here is divided into 2 equal parts, from here to here and from here to here. That again is true because we know that this triangle is isosceles. So that was a crucial piece of information to solving this problem, right? And of course, if you're an equilateral triangle, you're automatically an isosceles triangle, so you inherit all of the properties of an isosceles triangle, right? Okay. But so how does this help? Well, because now you have 2 right triangles, right? And I'll just draw it on this side. At least for me, it's like better or easier on this side. So I'll do that. So then, like, since as we said, this is bisected, meaning cut into 2 equal parts, and the distance from here to here is 2. It must mean that this part here is 1, and this part here is 1, right? So on the little triangle, I'll shade it. On the little right triangle, I should say, because it's a right triangle, we know that this here is 1, okay? Got it. And we also know that if we name this angle right here alpha, alpha exists both in this little triangle and in that triangle. It's the same angle, right? It's shared both by the little triangle and by the big right triangle. But notice that the location of the right angle on the two triangles is different places. And the big triangle is right here, and the little triangle is right there, right? Anyway, let's not forget to mark that. We've got that, we've got this. There are two solutions to this problem, right? Okay. Got it. So, where to from here? Well. So, since we know that this here is 4, and it is the hypotenuse of the little fella, right? I put 4 here, and you could do simple Pythagorean theorem, but this is root 15 now, right? Okay. And on the big right triangle, this is r, which is what we're after. So I'll be like, this is r. And notice that by the angle theorem, we know that these two triangles are similar. We have an angle here, which is equal to an angle there. We have another angle here. So this triangle is just a scaled version of this triangle. Got it. So if only we can figure out what the scale factor is. Well, we can set sides proportional and go from there, right? So we'd be like, r over 1 is equal to, so we went from this to this. So like what we're after is, do we know this side here? We need that, right? And we do. And this is sweet, right? This is really cool. So like by that theorem I said earlier, that tangents from the same external point are equal. We know that this distance here is the same as that distance. This distance here is 1, so we know that this distance here is 1 also. So together we have 4 plus 1, that's 5. So we know now that this is 5. So we're good. So we go r to 1, I go r to 1 is 5 to square root of 15, and so here we are. So r is equal to 5 over square root of 15. Now, if you want to rationalize the denominator, that's easy task. And there's actually a profound reason, I forgot why we must do that. If anyone wants to chime in, feel free. But yeah, so this is one way to solve the problem. There's a different way to solve it, and this other way to solve it is using trigonometry. Notice that tangent of alpha, right, is opposite over adjacent, right? So in this little triangle, tan alpha is equal to 1 over root 15, right? And so that's tan alpha. But also in the big triangle, we have tan alpha. Tan alpha is r over 5, right? So tan alpha is r over 5 in the big triangle. And so to solve for r, we could get rid of this phrase tan alpha in the middle, multiply by 5 on both sides, so times 5, and we have r is equal to 5 over square root of 15, right? Okay, same place. Now, the reason why we're able to set tan alpha in one triangle equal to tan alpha in the other triangle is because the two triangles are similar, right? So if I have a triangle here, right, and I scale it, I make a bigger version of it. So this is a bigger version of the triangle. Sorry, this doesn't seem like it came out clearly, but yeah. If I have, sorry. So this is alpha, this is alpha. So if this side is x, they both have to be right triangles, right? So if this side is x, let's say you use a scale factor, and this is kx, and this is y, and this is ky. Notice tan alpha in here would be x over y, adjacent over hypotenuse. In here, it'd be kx over ky, right? But then the k's drop. So I can cancel the k's, and I see that I'm going to get x over y. Same thing. In other words, the trig ratios, sine, cosine, and tangent, are only dependent on the angle, right? The input is the angle. They don't care about, the size of the sides, right? Okay, so long as the angle is the same in the right triangles, then the trig ratios will put out the same value. Okay, cool. So, hope everyone enjoyed this. Christ is God. Fear no one else and nothing else. Only Christ has any power above you. These are little roaches who have small whinnies and a little bit of money. They sniff a lot of coke and drink a lot, and since they live a miserable existence, they get these ideas of, oh yeah, how can we drag everybody else into our miserable existence? Just let Christ hit them, they're little roaches to him. I can't wait until Christ puts you out, stamps you out like the little roaches you are. Jesus is God. It should be painfully obvious for anyone who's like getting the wrong idea that like the battle we fight is spiritual. So the battle we fight, and of course like it has like real like life consequences, because like this, I've talked about this like to other people before. It's like the spiritual world is like what is it? It's like the magnetic field. It's there, but you can't see it, right? Like, so you guys have seen this, like you know, if you take like a piece of paper, right, lay down a magnet, and then throw iron filings. So that's like little pieces of iron. You can see the outlines of the magnetic fields on the paper via the iron filings, right? It's like that, which is like the spiritual world has real life consequences, because it's out there, it's here, like just can't see it, right? And so it's like it has real life consequences, but like, you know, there's a lot of diversity in the spiritual world, which is that like the people who work for the enemy, they come from all colors and backgrounds. There are white people in it, there are black people in it, there are Asian people, there are a lot of people who work for the devil. Just like that, there are a lot of us, like, and at least like 3 billion strong, like there are like about 2.3 or 2.7 billion, 2.3 billion strong, blah, 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 blah. Now, you know, not all of us, even myself included, like are always on that straight and narrow that Christ talks about. But, you know, we must work hard, never tire. And, I mean, it's not only written that we will win. But, you know, like, they don't stand a chance. It's just like I said, they're little roaches. Like, I've said this in the past, I'll say this in this video later, in this video, they're little roaches. They're like, you know, nuisances, as John Quincy Adams said. Freemasons, again, I dare you. If you want to fight, you know where to find me. I dare you. Come get it. This is a tap out game that we will win. We'll tap out.